Okay, thank you, Ram. So, okay, I'll start with what some highlights about this week 4 sessions. So, week 4, you have gone through the videos, right? So, okay, people are joining. So, let them join meanwhile. So, I'll start with my presentation. Okay, Yashwant. Now, am I audible? Okay, thank you. So, we'll start, first of all, we'll start with the theory part of optimization. So, in this week, your assignments will be for solving problems on certain optimization problems, and then you can try doing those problems in R. Okay. So, what do you mean by optimization? So, this you might have seen in your pre recorded lectures also. So, the Wikipedia definition is like, yes. So the Wikipedia definition is like it consists of maximizing or minimizing a real function by systematically choosing input value from within. Okay. So it's the use of a specific method to determine the best solution. So can you tell me why we use optimization or how it is related to a data science problem? So you can see the figures there, right? These are two of the main scenarios that you can encounter in a data science problem. So the first one, it's showing like it's like we want to find a line which will represent the data, and it should be nearer to the points in the data. And the second one, second picture that is shown there, that is for classification. So it's like we want to see a best line that will classify the data. Okay, so this is for a regression problem, meaning like your end value or your target value will be a continuous variable, and this is for classification, meaning like your end or target value will be any one of the classes. Okay, either, so in this case, it will be either this class 1 represented by the red dots, or it will be like these class represented by blue crosses. Okay, so that is, so that is why optimization is used. We will use these optimization techniques in our data science, machine learning, and deep learning problems. Okay, so the first one, the first type is univariate optimization problem. You have seen this already. Okay, this curve you might have seen. You might have seen the local maximum, global maximum, local minimum, and global minimum, right? So some of more important things to take care of there is like first one is the objective function. Next one is the decision variables, and third are the constraints. Okay, so this is the thing that you'll usually observe. So you'll have an f of x, which is a function, objective function. Your objective will be like minimizing it usually. There can be maximization problems also in the real world, but in a machine learning perspective, usually it's like minimizing. Okay, so if it's machine learning or deep learning, you will be having a cost function there. So your um, intention will be to minimize the cost function so that your predicted value will come close to the original value. Okay, so this is the univariate optimization problem. Okay, now univariate, it varies with one variable. Okay, now, so univariate optimization conditions are, first one is minimize f of x for x. So the necessary condition should be like f dash of x is equal to 0, and sufficient condition should be f double dash of x should be greater than 0. This is the minimization condition. Okay, so this one, these two conditions are the base of many of your problems in the assignments. Okay, so if it's to be a maximizer, then it will be like the first derivative f dash of x equal to 0, and the sufficient condition should be f double dash of x should be less than 0. Okay, so that is the difference for a minimizer as well as a maximizer. Okay, now can you tell me the answer for this one? The minimum or maximum of f of x exists when? Choose option A, B, or C. Okay, you can put in the chat window. Yes, okay, so that's right. That's right, everyone. So the maxima of f of x exists when? Answer for this one, the second one. That is the sufficient condition for that. Okay, the maxima. Yes, the maxima exists when f double dash of x is less than 0. Okay, so I'll just highlight that. This is B, and the answer of this one is C. Okay, so just we'll see some questions. So some of these questions are coming up in your assignment, I think, which the due date is tomorrow. So this is just an equation like f of x is equal to x raised to 4 by 4 minus x cube by 3 minus x square. So the first order condition, this is the first order condition, f dash of x is equal to 0. So f dash of x will be equal to, you can solve this like 4x raised to 3 by 4 minus 3x square by 3 minus 2x equal to 0. That is leading to this equation. And solving above points, you'll be getting these values. Okay. So the first one, how can you solve this one? Is it fine for everyone, or should I solve this one? Okay, so I'll just immediately do it. Okay, you can take x out from the equation, and it will be like x square minus 3x minus 2 equal to 0. That is why one of the equations are coming up as x equal to 0, and the rest of the one, it's like you can get like x, this particular x square minus 3x plus 3x minus 2 is coming, right? So it will be like, how can you do it? Equal to 0. I mean, if you solve this, it will be coming like x plus 1 into x plus x minus 2. Okay. If you solve this one, it will be coming like this. Okay. That is why x is coming as minus 1 and 2. Right. So these are the conditions. This is the condition that we are getting. Now what you have to do? Then we have to find the second derivative also. F double dash of x equal to 3x square. Again, taking the double derivative of this equation will come like 3x square minus 2x minus 2. Okay. Now, what you have to do is like, you have to substitute each of these values. F double dash at x equal to 0, at x equal to minus 1, and x equal to plus 2. So, when you are substituting, anyway, the steps are written there. The first one will give minus 2, next one 3 and 6. So, what is the condition for minima? Minima should be like f double dash of x should be greater than 0. So here there are two conditions where f double dash is greater than 0. That's why we are finding out f of x values at these two values, minus 1 and plus 2. And we'll get these two values in that case. And so we will be choosing which is the minimum value here, this minus 2.667. So the minima x is at plus, x is equal to plus 2 with the value minus 2.667. Okay. Now next one, this is also a similar one only. Of all the rectangles of area 100, which has the smallest perimeter? Okay. So in this one, it's given area is equal to length into breadth, perimeter is equal to 2 into L plus B. Okay, yeah. So optimization function is the perimeter. It's asked like the minimum perimeter. Okay, so it's a minimization problem. So minimization conditions are like f dash of x, it will be like equal to 0, and f double dash of x should be greater than 0. Okay. Kavita, why have you put f of x less than 0 like okay, Ram, is minus 1 not the solution? Why? Why are you telling? Okay, 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 okay. So there is a problem. Okay, okay. Let me see that. So can you solve and tell the answer? So there is some problem in the question. I forgot to notice it. Okay. So it's coming like, okay, just a minute. Hmm. Okay, so this condition was like, it should have, okay. Yeah, it's a quadratic equation. The values are coming like minus 0.56. Okay, so you can solve for that. Okay, minus 0.56 and 3.56. Okay, so just wait a minute. X is equal to minus 4. Okay, x is equal to 3.56, and it's coming like minus 0.56. Okay, yeah, so it will be like an equation which, so what you can do is like you can place these values in the equation above, okay, and you can find out whether it is a higher or lower. So we will, I mean, you can solve it later. So what you have to do is, this procedure is similar only. Instead of this one, x is equal to -1 and +2, you have to substitute 3.56 and minus 0.56. The decimal points are coming. If you are like solving it with the quadratic equation, you'll be getting a root value. Okay, that's all. So sorry for this one. There is a mistake in this one. Sorry, I didn't notice that. So the next one is like, yeah. So the next one is like, the perimeter is equal to 2 into L plus P. So we have to minimize um, these perimeter. Okay. So for that, the function is like 2 into L plus 2B, means 2 into L plus P. And in that 2L into, instead of the breadth, I am giving like A by L. So we'll reach in this equation 2L plus 200 by L, because area is given as 100. Okay. So applying the first order necessary condition, this one, and f dash of L. Okay. So f dash of L is equal to 2 minus 200 by L square equal to 0. Then, so if you solve the above equation, what you will get, that you can find. Okay, so it's like, it will be coming like 2L square equal to 200, then L equal to plus or minus 10. Okay, so this you don't have to go for the double derivative because length cannot be negative. Okay, so that's why we'll take this one as 10, and then calculating from that the breadth is 10, then we can find the perimeter. Okay, so we don't have to calculate any plus or minus, I mean any second derivative in that equation, because physically minus 10 is not possible. So yeah, so till these two problems are fine with you, right? And I didn't understand what Kavita had written, f of x less than 0, meaning you meant like the minimization problem means f of x less than 0. Is that what you meant? Can you explain what you have written there? Um, okay, then Kavita, you can tell later. Okay. So, okay. Okay, Kavita. So, next one. And manufacturer determines that the daily average of producing Q units is determined by the number of units produced per day, which minimize the average cost. Okay, so this is another function. So this is the optimization function here, which is C of Q, and Q is the decision variable. So in that, first what you will have to find the similar steps only. So here, the first thing is like C of Q. This is the function. First order condition will be like this. Okay, f dash of 0. So if you equate this to 0, then the value will be coming. You can do it later and find out. The critical value will be coming as q is equal to 500, and then we'll check the second derivative also. So the second derivative is coming like this value. Okay, so if we substitute q equal to 500 units here, then it will be giving a positive value, because anyway this is a positive function, there is no negative values there. So anyway, c double dash of q will be greater than 0, meaning like this particular point is the minimum value. Okay, and after substituting this q in the initial equation, you will be getting the C of Q value, which is the minimum value. Okay, so the minimum value is coming like 60, that is given there. Okay, Now, multivariate optimization. So, in multivariate, there will be many variables. Okay, and one of the this you have seen in your lectures also. So we'll be putting in a contour plot, we'll be putting like root of x1 square plus x2 square. This is the function which you can see in such a case. This is like a convex uh, figure. Okay, and this is like a contour plot for increasing values of z. This you have seen in the slides earlier. So for multivariate optimization condition, if z equal to f of x1, x2 up to xn, the necessary condition is like this gradient. This del f of x should be equal to 0. Okay, so it's given there. That means that dou f by dou x1, dou f by dou x2, and dou f by dou up to dou f by dou xn. Okay, this has to be equal to 0, and you'll find the conditions, points where it is possible. Now, the sufficient condition, this one, the Hessian matrix, it has to be positive definite, meaning like the values you'll be getting there are all positive. Okay, so we'll see this in an example. So the first one is like find the first and second order necessary conditions for the function and tell whether the minima exists or not. Okay, so the first function is like x1 plus 2x2 plus 4x1 square minus x1 x2 plus 2x2 square. Okay, so the first order necessary condition equal to del f equal to 0. Okay, so can you tell me how you calculate del f equal to dou f by dou x1 and dou f by dou x2? This is the matrix that you have to find, and in that one you will be getting like 1 plus 8x1 minus x2, right? Are you getting like that? Okay, just solve yourselves and see if what I'm writing is fine. Okay, next one is 2 minus x1 plus 4x2. Okay, 2 minus x1 plus 4x2. Yeah, so this is equal to 0, 0. Okay, so you'll be getting two equations. It's something like, I'll just write here. It'll be like 8x1 minus x2 equal to minus 1. Sorry, equal to minus 1, and 2 sorry, minus x1 it will be like minus x1 plus 4x2 equal to minus 2. Okay, so you can solve for this one, or you can solve in the calculator also. Okay, so you'll be getting x1 x2 as minus 0.19 and minus 0.54. Okay, so this you'll be getting. Shashank, these notes will be given in the will be shared in the Google Drive. You can just see from your announcements tab. Okay, in your course, it will be shared. I have shared all week 1, week 2, and week 3 slides as well as YouTube links in that drive. Okay, yeah. So this I'll be sharing today. Okay, so the thing is like checking. Then first we have given like x1 x2 we have got. Now we have to find the second derivative. Okay, so the second derivative is like you have to find dou square f by dou x1 square. So how can you find that? Can you tell me how will you find dou square f by dou x1 square? that will be like dou f by, sorry, that will be like dou by dou x1 of dou f by dou x1. So dou f by dou x1 is already found out, right? Again, one more time. So it will be coming like 8. Okay. Similarly, you can do for dou f by dou x2 differentiated with x1. So dou f by dou x2 is 2 minus x1 plus 4x2. So dou f by dou x1 here will give you minus 1, right? So yeah, it's here minus 1. Then next one is dou f by dou x2. I mean, it's like symmetric matrix only. This Hessian matrix is a symmetric matrix, so you don't have to calculate, but still the same value will be coming. So minus 1. And then dou f by dou x2, again differentiated with x2, will give you 4. Is this clear for everyone? If you have doubt, please raise your hands or you can ask directly. Okay, so this is the matrix that we'll get. Now you have to find the eigenvalues. Okay, so this is right now a matrix. So 8 minus 1 minus 1, 4. So for finding the eigenvalues, either you can use the normal method like determinant of a minus lambda equal to 0. A is your 8 minus 1 minus 1, 4. That is your thing. Or last class for week 3 assignment, I had told you like if you put it as a vector, sorry, if you put it as like a matrix, and store it in R, okay, in a variable named A, and then after that if you give eigen of A, then you will directly get the eigenvalues. Okay, so you can use any method. Okay, so then I'll be showing you one example. So no, I have already shown the example in week 3, so you can just refer to those notes, and that is one method, or you can use the normal method itself. Okay, so the eigenvalues of the matrix are SEN matrix are 3.76 and 8.23. They both are greater than 0. So this matrix is like positive definite and minima exists as all critical points. Okay, so that is the answer. So is this fine? If it's not fine, you can tell me. Now, next, gradient descent method. So this one also you have seen in your lectures. Okay. So it's like applicable to find the minima of a given function and applied in the backpropagation algorithm. This you'll find most of the applications in the neural networks. So does anyone have any doubt? Okay, I'll continue. So in this one, you have to find the next point. So it's like xk plus 1 is the next point, and your starting point is like iteration. Every time you will initialize one value in your function. Okay, so the initialized point will be like x raised to k xk, and that using that xk and one learning parameter. Okay, so it's like the next point you will find with the help of this learning parameter as well as s raised to k. So that s raised to k is like gradient of f of x. Okay, and the negative of gradient, so it will give you the direction. Okay, and alpha k is kind of the step size. Okay, so we'll see. This is like what you'll see in the gradient descent problems. So you'll start at a point here, then you'll try to come to the other point, then it will be like this. So if the learning rate is low, it'll be like coming to the next point like this, like this. So it's like usually you can see this in neural network problem. If the learning rate is very fast, then it will go like very fastly and rapidly, and you miss some of the points. Okay, now this one is an example. We'll see this one. So f of x is given, f of x1 x2 is given as x1 square minus 2 x1 x2 plus 2 x2 square plus 2x1. So you can find the del f for this one, right? So del f equal to dou f by dou x1, dou f by dou x2. So you'll be getting this one as written there, 2x1, sorry, 2x1 minus 2x2 plus 2 and minus 2x1 plus 4x2, right? So initial values will start at 0 0, right? And the step size is given. So these two are given there. So step size is already given there, and initial value is also given. So what you have to do is the next one, x1 equal to the first one, initial one, x0 plus a s raised to 0, meaning that x0 you already know as 0 0, and alpha value is 0.5 into 2 into x1 0 minus 2 x2 also 0 plus 2. Here also 2 into minus 2 into 0 plus 4. So your value will be coming like minus 1 0. Similarly, so you have got x1 like minus 1 0. Now x2 equal to x1 plus alpha is 1. So it's like x1 minus alpha into del f. So in this case, x1 is minus 0 1, and here also this will be solving like this one. Okay, it's straightforward only, and the answer will be coming in this way. So the question it is asked like values of minima found after 3 iterations for the function. So since it's asked only up to the third iteration, we'll be stopping in the third iteration, which is x3. Okay, so I hope you have understood. If alpha k learning parameter is constant or change with the iteration. Okay, no, alpha is constant in each iteration. Why are we putting k as subscript? Okay, why aren't we? Yeah, you can use it as a subscript. There are different notations can be possible. Whatever you have learned in your lectures, you can continue with that. If you have learned like xk, x1, x2 like that, it's fine. Okay. Now alpha, the learning rate, it has many different importance in neural networks and all. It's one of the parameters that you'll be changing. Okay, in neural networks and all, you'll be naming it as learning parameter. Yes. So alpha, you'll be putting different values to see how your performance varies. Okay, and as the alpha value varies, you can make the learning fast as well as slow. So sometimes if it's very slow, you might be catching every point, and maybe it will be leading to overfitting. Okay, that's one of the problem that can happen. Sometimes if you're putting a learning rate as a very high value, then it will be like it will lead to a fast, I mean the iterations will stop very rapidly, but still it will be, that model will be an underfit model. Okay, so is that right, Ram? Is that okay? So right now in this question it's constant. Okay, usually in learning also it will be constant, but we have many different methods like grid search algorithm, and we can mention the learning rate parameters. Okay, so if you can put it as a matrix and say like learning rate should be points 1 0.01 0.001, so and the model will be calculated, model will be formed for each of these different values, and you can compare them. Okay, yeah. So this is just an introduction to all the things. So now I'll move on to the assignment problems of the previous run course. Okay. So this is the week 4 assignment. So the first one, these are all very simple problems. I have seen yours also. It's kind of similar only, so you can learn from this one. So f of x equal to 3x raised to 4 minus 2x cube minus 3x square plus 6. Okay, so this is like the question for 1 to 4. Okay, so first thing is like first order necessary condition for either maxima or minima of f of x. Can you tell me first order necessary condition? Yeah, answer Ram has put as B. Okay, anyone else? I'll just show you fastly. What is the first necessary condition? Sorry, the answer is B only. Yeah. So first you have to find f dash of x and equate it to 0. Yes. Then so it will be coming like 12x cube minus 6x square minus 3, sorry, minus 6 x equal to 0, something like that. So it will be like 2x into x square minus sorry, it will be like 6, sorry, 6x you can take. So 2x square, let me just erase this one. So it will be like, so if you're taking 6x outside, then it will be coming like 2x square minus, yeah, minus x minus 1 equal to 0, right? So you'll be getting some values like, what were the values you were getting? X equal to 0, yeah, it is there. Then it might be um, x equal to 1 and x equal to minus 1 by 2 will be coming. It's equal to 1 minus 1, 2. Can you calculate once more, Vamshi? Because you just see if it's coming x minus 1 into x plus 1 by 2. Yeah, so it will be like, I'll just minimize this once more, okay? This one can be written as x square minus 1 by 2 x minus 1 by 2 equal to 0. Okay, so is this fine? So in this way, this one's answer also will be like x square plus 1 by 2x minus 1 by 2x will be minus 1 by 2x minus 1 by 2. Okay, so Vamshi, it's like 0, 1 and minus 1 by 2. Okay, so that is fine. Yeah, then f double dash of x equal to 0. So f double dash of x, sorry, f double dash of x you have to find out. So again 24 x square minus 12x minus 6. Yes, so you have to put these values. X equal to 0. X equal to 0 will give you some values. Can you tell me anyone who has solved? Minus 6 will be coming, right? So x equal to 1 will be coming like, how much will be coming? 4. No, 6 will be coming, right? Yes, and x equal to minus 1 by 2 will give you 6 plus 6 minus 6. It will also be 6. Is this right? F of 1 is like a different weight. F of 1 will be 24 minus 12. Is this fine? Oh, I have made a mistake here. 36 will be coming here. Yeah. That is x square minus 12x minus 6. Yes. it will be minus 6 only, and here it will be 36 minus 12 minus 6 equal to 18, and here it will be 36. Okay, it will be 18. Sorry, 6. Just solve this one and tell me. Nine is coming. Is 9 coming for everyone? Okay. Okay, wait then. Yes. So, okay, let it be 9. Sorry. Yes. 9 will be there. Okay. So, mm, so can you tell me which is the answer? Why have you selected the B option in that case? So, first one, this is B, right? Okay. So we have reached up to that level, 12x cubed minus 6x square minus 6x equal to 0. So in this case, the answer is B, right? This is the answer. Now, okay, I'll stop up to here, like minus 6, 18 and 9, and we'll look at the other question. So if you want to see, this is the answer. Now the next question is like asked, which are the stationary points, that also you have found out. So it's like minus 1 by 2, 0 and 1. Okay. Next is like the stationary point which maximizes the value of f of x. So this one you can tell. Maximizing the value of f of x. So right now you have got like f double dash of 0 as what have you got there? F double dash of 0 as minus 6, right? And f double dash of 1 as, yeah, B second option is 0. Yeah, that is right. Just tell me what f double dash of 1 was. Is it 18? Yeah. Then f double dash of minus 1 by 2 was 9. Okay, so from this, maximizing the value means f double dash of 0 should be less than 0. That belongs to this condition. So the answer is 0. Okay. Now the fourth question is like a stationary point which minimizes. So you have seen f double dash of x. Minimizing means it should be greater than 0. So the value was greater than 0 for minus 1 by 2 as well as 1. So these are the two options. Okay. Solution is A and C. Okay. Now, what if the two values are less than 0? Yes. So here it's like f double dash of 1 as well as minus 1 are greater than 0. Okay. So this is like for the minimization case. Okay. For the minimization case, two cases are coming. So in that case, what you can do is like you have to substitute these two values in f of x at x equal to, so two values are coming, so at x equal to 1 as well as minus 1 by 2 you have to find, and then you have to see which is the value. I mean, for example, in this case, f dash of double dash of 0, in these two cases, f double dash of x is greater than 0, which is pointing to minimum value of f of x, right? So two values are there. Since two values are there, you have to find f of x values for these two values. You have to substitute 1. So for example, f of 1 you have to find out, and f of minus 1 by 2 you have to find. Okay, so f of 1 will be like 3 minus 2 minus 3 plus 6, right? So it will be coming 4. F double dash should be 6. Which one? Aditya, which one are you telling about? F double dash of 1 should be 6. Okay, somebody had told like 18. So others, Ram, you have got 18, right? I have also got 18. Wait, so let me see. Hmm, okay, so F double dash of. Okay, we'll solve that. So F double dash of. Wait. Hmm, F double dash of x equal to just double dash was coming like how much? 336 x square minus 12x minus 6, right? So f double dash of 1 is like 36 minus 12 minus 6. This is 18, right? Aditya, are you not getting this equation? Okay, yeah. Okay, fine. So, so in this case also, I have stopped at f of 1. F of 1 is like 4, and f of minus 1 by 2 will be, it's like, it's difficult. Yeah, 3 by 16 minus 2 by, so it's like plus 2 by 8 minus 3 by 4 plus 6. Anyway, it will be a positive number. Yeah, you can solve it and find out if you have a calculator. Okay, can you find it out? I'm also solving it. Can you tell me the answer? Yeah, 5.6875. That's right. So 5.6875. So which is f of 1 and f of minus 1 by 2, which is greater? F of minus 1 by 2 is greater. Yeah, so the maximum value, right? Sorry, I'm sorry. F dash of double dash of x is greater than 0 for, so these two conditions we were seeing for minimum of x. I just looked at the question. So we have to see the minimum. So which one will be the minimum? Which one will be the global minimum? yeah, minimum at f of equal to 1. So you can write like global minimum at x equal to 1. Okay, yeah. So that is all these questions. Okay, from 1 to 4. Next we'll move on to, so the stationary points which will minimize the value of f of x will be minus 1 by 2 and 1. Okay. Now similarly one other question. Find the minima of the function f of x equal to this one using gradient search method starting from x equal to minus 6 and learning rate alpha equal to zero point 0.5. Okay, so this one a similar question we have seen earlier. Okay, so this is like f of x, you have f of x equal to x minus 5 whole square minus 5. Okay, and starting place is like minus 6, alpha equal to zero point 0.5. So can you tell me the next equation for the next one? Hmm? So it's like, how can you start it? x of, sorry, x of k plus 1 equal to x of k minus alpha into this gradient f dash of x of k. Okay, so for that f dash of x you have to find, it will be like 2 into x minus 5, then f dash of, what is the initial function, f dash of minus 6, that will be like value like minus f dash 0.5 minus 6 into minus 2 into minus 6 minus 10 by, can you explain, Ram? Okay, this is like, yes, minus 6 minus alpha is zero point 0.5, right? F dash of x of k is 2 into x minus 5. X is minus 6 minus 5, right? Okay, you have, yeah, that is fine. Okay. So the f dash of minus x will be coming like minus 22, right? So minus 22. So this answer will be, yes, yeah, the answer will be, yeah, Vamshi, why that answer? 11 minus 6, yeah, 5 will come. Yeah, that is right. Now, what is the next thing? What do you have to do next? You have to repeat this again. Okay, so it's like the next one, k plus 1. So this is like, so first one was like x0 we had, this one was x1. Okay, now x2 you have to find. Okay, so x2, what will be coming? x1 minus alpha f dash of x1. Okay, so this will be 5 minus zero point 0.5 into 2 into 5 minus 5 is equal to 0. So it will be coming like 5, right? Is that right? Yeah. So x1 you got 5, x2 you got as 5. So it's like not changing. Okay, there is nothing happening to the values. So you can stop at this one. Okay. So question is like, find the minima of the function using gradient search and use the correct statement. So you can see this one, x1, x2, you'll be getting 5, 5. So all iterations are giving the same value for x. Then the minimum value for x is 5. Okay, yeah. So x minimum is equal to 5. Then we'll find what is the minimum value for the function. So f of x minimum will be 5 minus 5 the whole square minus 5 will be like minus 5 is the answer. That is the minimum value for the function. So in case if x1 and x2 are different, then some in the question you'll be like find the third iteration, find the value after the third iteration, or like that it will be mentioned. Okay, in this case it's not varying. Okay, it's not varying in this case, so we have stopped at this level. Okay, is this clear? If you have any doubt, you just mention that. Okay, yeah. So the gross, next question, like, is the gross domestic product of a country in billion dollars following a crisis at t equal to 0 is given by g of t equal to minus 0.1960 q plus 3.244 t square plus 9.179 for 0 less than t less than it equal to 28. Okay, when is the GDP highest? So GDP highest means you have to maximize G of t. Okay, so similar steps only you have to solve for this one. So first the initial step, I'll just give you some moment to solve it. First you have to find out what is G dash of t, right? Can you tell me the answer after solving? It will be like 0.196 into 3 t square plus 2 into 3.244 t plus 0. Okay, so you'll be getting g dash of t as, just find out quickly and tell me. Answers are given like this. Okay, options are like this. So it will be coming around like 0.196 into 3 will be coming like minus 0.588 plus 3.244 into 2 will be coming like 6.488. Okay, so here it will be t square and here will be t. Then you have to give g dash of t equal to 0. Then you'll be getting the t value as 6.488 divided by minus 0.588. Can you tell me the answer? What you'll be getting? Yes, that is right, Vamshi. 11 point, sorry, we'll be getting like 11.034. Okay, so that is coming in our option. 11.034 is coming in our option, but wait, anyway we have got one value only. We have to check whether it is the maximum value. Okay, so we have to see the g double dash of t. So g double dash of t will be 0.588 into 2, that will be like minus 1.176t plus 6.488, right? So in that you have to substitute your 11.034. Okay, so this into 11.034 plus 6, so it's coming around minus 6. What value is coming there? I'm just calculating once more. Okay. 6.488. So yeah, Pooja got, why are we not considering t equal to 0? Yeah, that is also there. We have to consider. Sorry. T is equal to 0 also, and t equal to 11.034. These two are there. Yes, Aditya, it's there. So g of t double dash of 11.034. I didn't consider it because options are coming like this. Okay. No, there is no 0 there. So can you tell me? So this one was, what was the answer? Minus 6.488. Okay. 4879 and g double dash of 0. Yeah. What value are you given for 5.177? What is that value, Pooja? G dash double dash of 0 is negative. Ah? Okay, Pooja. Okay. So just okay. What is this one? So this was 11.03 was coming like minus 6.488, and G double dash of 0 is coming like 6.488. Yeah, that is fine. So yes. So which value? Where it is positive, where it is negative. This value is like less than 0. This one is greater than 0. Our question was like GDP is the highest. So for GDP is the highest means maximizing that GDP value. So maximizing means T double dash of this thing should be less than 0. So it's less than 0 at T equal to 11.034. Yeah. That's why the answer is that B. Okay. This is the answer. Okay. So you can just read through this one later. Okay. Now, the next question is like a function is defined as f of x square plus 70x plus 12. Okay. Find the value of x at the stationary point. Okay. So tell me, what is a stationary point? F of x equal to 7x square plus 70x plus 12. Yeah. Okay, Ram has put D. Ma'am, can you explain stationary point? So stationary points are points where this f dash of x will be 0. Okay, so it will be like the solution to your this equation. Okay, is that fine, Aditya? In the curve, it will be like in one if one curve is there, it will be like your derivative, where your derivative is 0. Yeah, so it will be like a tangent to that curve. You might have studied it earlier, right? Okay, so negative 5. Okay, is everyone's answer that one? Okay, yeah, that is simple only. You have to find f dash of x equal to 0. It will be coming like 14x plus 70, right? Then If you put it as 0, then it will be coming like minus 5, right? Then you have to find, you can continue and find the whether it is maximum or minimum also, okay? So right now this is the stationary point, okay? So difference equation it to 0 gives the stationary point or points. Right now it's negative 5 only. So from the given equation, x minus 5 is a stationary point of the function. Okay. So now you have to give the answers to these questions. Can you give the answer to this one? Class of optimization problems with no constraints are known as? Okay, B. Kavita has given constraint. Okay, version 2. Yeah, that is right. So this one is the answer. It's like unconstrained optimization problems. Right. Next one. Optimum of a function f of x at x star exists if what is the necessary condition? First derivative should be, yeah, that is right. Next one, when the feasibility regions defined by the equality constraints and inequality constraints are compared. So this is kind of a portion that is coming, I think, in your week 5 also. So right now I can tell you is like in this case, okay, the region defined by the inequality constraint will be greater. Okay, you will see that in week 5, I think. Okay, so I've just put this equation there. No, sorry, this question there. Okay, after that I'll explain in that. Okay, so in this region divided by inequality constraint will be greater. Okay. Now, if f of x equal to 12x raised to 4 minus 2x cubed plus 9x square plus 5, can you tell me the first order necessary condition for either maxima or minimum? So, just want to find out the first order necessary condition. It's very, yeah, straightforward only. B only, yeah. So, it's 48x cubed minus 6x square plus 18x equal to 0. Yeah. Now, the restrictions on the possible values of the solution to the optimization problems are called. So it's coming from previous question only. Yeah, the answer is C. Okay, the answer is C. Now I'll just give an example using R. Okay, so in R, there is a library which will help you to find out the optimization problem. Okay, so this is like the question is like a company wants to maximize the profit of two products A and B. So two products are there, A and B, which are sold at $25 and $20. Okay, per piece. There are total 1800 resource units available every day, and product A requires 20 units while B requires 12 units. Okay, both of these products requires a production time of 4 minutes total. So production time is 4 minutes for A and B, and total time is 8 hours per day. That means like 8, since it's in given in minutes, it will be 8 into 60 minutes. Okay, yeah. So, and total hours. So, what should be the production quantity of each of the products to maximize the profits? Okay, so this is a maximization problem. So, we have to maximize the sales. So, what is the production quantity? It's asking. So, maximize this equation. That means 25 into the number of units of A and 20 into the units of B produced. Okay, which are, yeah, I'll come to that, Aditya, right now. Okay, so first we'll solve here. So now the first equation is like maximize 25y1 plus 20y2, that is your f of x. Okay, now these are the constraints. This I think you might have seen. So it's like 20 units should be required for A and 12 units required for B, and total resource available is 1800. So this is the resource constraint, and time taken by both like 4y1 and 4y2 is less than 8 into 60. This is the time constraint. So you have an f of x, you have this one as well as resource constraint as well as time constraint. Okay, so all these things, you should have an objective function, you should have the variables. Okay, so that y1 and y2 are there, and you should have you will have some constraints which will decide what your problem will be, maximization problem will be. So the whole objective is like you have to maximize the sales. Okay, so I'll just shift to the R window right now. So okay, just wait a moment. Okay, yeah, I have already kept this. So this is the question. Okay, I hope you can see this one. So this is Aditya. You have asked, no, this is the library that you can use. Okay, LP solve. Okay, so first you have to install that and bring it to the live, bring it to the console. Okay, so LP solve. If it's not there, then go to your install, search for LP solve. There is LP solve. Both libraries are there. This one is only Geeta. Okay, yeah. So this is LP solve. This one you have to install. Okay, otherwise you will be getting an error. Okay, now I'll be giving like what is our first constraint. Our first constraint was like, sorry, this was our first constraint. Okay, 25y1 plus 20y2. Okay, so now this you have to store in a variable. Okay, so this is our objective. Objective dot in is equal to, you're storing it as a array. Okay, C 25 comma 20. So if I print this one, you will be getting objective dot in as 25 and 20. Okay, now you have two constraints, right? Time constraint as well as resource constraint. So this one you will be storing as a matrix. Okay, so I'll just show you that constraints here. So that constraints were yeah, 20 12. So you'll be writing this as um, matrix 20 12 4 4. Okay, so likewise 20 12 4 4 as a matrix, and number of rows is equal to 2, and the arrangement will be like by row equal to 2. So it will be coming like, so if I run this one, sorry, if I run this particular thing, we'll be getting like 20 12 4 4. Okay, so now you have declared a matrix like this. Now you have to mention which row points to which constraint. So for that, I'm just mentioning, I'm just giving these values. So time constraint was 8 into 60. Is that right? 8 into 60 was the time constraint. So I'm just putting in that variable, and the resource constraint was 1800. Okay, so these two are fine. So if just I'm printing these both now, so time constraint came as 480 and resource constraint 1800. Okay, now you have to tell that these two are the RHS of the function. So right now if you look at these things, you will see that the right hand side of the equations are the values of the constraint, and the left hand side is the matrix, right? So I'm just putting like RHS equal is like C of resource constraint was the first one, right? Your matrix is going like 20 12 4 4, So resource constraint should come first. So that's why I'm putting resource constraint and time constraint. Okay. So I have saved it to RHS, that is a function. So it's coming like 1800 and 480. Okay. Now another thing is like direction. So why I'm giving like this, I'll just tell you in a moment. So direction means like what is your direction of the constraint. So here you can see this less than or equal to, less than or equal to. So you can put direction as C of less than or equal to, less than or equal to. You can assign like this one. Okay. So the direction is right now, it's like coming as a character. Okay. So character and 1 is to 2 like that. Okay. So you have defined the direction, you have given RHS, and you have given the matrix which is the LHS. Okay. So the final step is to find the optimal solution. So why I have given this all these things? Because the syntax for the optimization problem and which is solved by the library LP solve is like LP of first one is direction, the direction you have mentioned, which is like less than or equal to and less than or equal to. Then your objective. So objective right now is what is the required thing, 25y1 plus 20y2. Then it is like constant dot mat means like your matrix. Okay, so your matrix you have stored as what, constant. Okay, now next one is like constant dot dir, so you have stored it in direction. And next constant dot RHS, you have stored it in RHS itself. So now you want to find the optimal function. You can give it like LP of direction max objective dot in. Okay, and constant direction RHS. Okay, now if you print this one, it will be giving the objective function and it's coming like 2565. Okay, now if you want to see the summary of the things, different things which is there, like all these things can be calculated. Just I'll, yes, Varsha, the session is being recorded. Yes. Yeah. So these are the different things that you will get in a summary of the optimum function. So yeah. So if you just see like optimum dollar direction, then you get the direction. Then if you give like optimum dollar x count, then you'll get that value. So the number, the length of all these vectors are given there. So one thing that you can see here is like solution you can find. Okay. So for that optimum values for y1 and y2, you can find out by optimum dollar solution. Okay. So if you just start like optimum and if you put dollar, then you will get all these options. Okay. So anything you want to find, you can just see that. So if you want to find the solution, solution will give you what? It will give you the optimum values for y1 and y2. So that's what we had to find. So these are the optimum values when the production had to be maximized. Okay, so we are given like greater than, right? So 45 and 75, it's like an optimization problem. So the maximum sales you can find out like optimum underscore object val. Okay, so you can find this one is the maximum sales figure that you had already obtained when you had directly given that. Okay, yes. So this is how you can solve this in R. So you just can visit this site, as last time also I've given you a site where you can see how you can implement this in, yeah. So this one you can see here. So you can read through this site. Okay, optimization using R, right? So this one will have most of the things. So this is one example that you can, using this you can solve most of the problems. Okay, so usually You can solve the initial steps and you can find the eigenvalues using eigen. Okay. So if you want to find a linear optimization, if you want to solve it, then you have to install this library and you can use the rest of the things. Okay. So till now, is it fine? I think your present assignment also had similar problems only, and I think one problem was for um, like gradient descent, but it's a similar problem also we have solved. Okay, is anyone having any doubt? I think a similar problem to this one also is there. So is it clear for everyone? Solution in Python. Hmm, that I'll have to see. I haven't prepared it. Okay, so that I'll see. Okay, so Python, which you are usually using Yadav, Puneet Yadav, which ID you are using for Python? Yeah, Jupyter Notebook. So okay, so that I'll see. Anyway, the present solutions are given in R. Okay, yeah, one of the Hagen values. Wait a moment. Okay, so one of the eigen, it's not like positive definite. Okay, so that will be leading to that you can just go through the notes. Okay, that is one indefinite case like that. Okay, just wait a moment. Hmm. Have you gone through the present thing actually? Week 4, wait a moment. Yes, that is like yes, kind of a yeah, kind of a saddle point only. So I think you can stop the search in that condition. Okay, I think you can read your FAQ session in the week 4. Is it available to everyone? I think it's available to everyone. Sorry, I'm not sharing. Mm, four, five. Just go through this one, okay? Just go through this FAQ, and there it's written, okay? It's written in your, there in your week 4 FAQ. Okay, go through that. Okay, so anything else? Is there any other doubts that you're having? I'll wait for a moment. What in Hessian matrix? Okay, so I will just share with the thing, okay? So in that thing, I'll also give a thing. Just wait, I'll share the window. Okay. Mm, so, so I hope it's visible. So the Hessian is like this one. Okay. So when you have a multivariate optimization condition, then necessary condition you will find with respect to this one, and this sufficient condition is like, I mean, the same condition that you had for the univariate, like f double dash of x should be less than 0 or greater than 0. Similarly, this one is like this del square f of x star, that is known as the Hessian. So usually if you have two variables, it will be like dou f square by dou x1 square. All the diagonals will be with respect to those variables itself. So dou f square by dou x1 square, dou f by dou x2 square, dou f by dou xn square, those will be the diagonals. And the other things will be like dou f by dou x1 x2, then dou f by dou x1 dou x3, etc. up to dou square f by dou x1 dou xn. Okay. Similarly, the second row will be like dou f by dou x2 dou x1. Then it'll end like dou square f by dou x2 dou xn. And the last row will be dou square f by dou xn x1 up to dou square f by dou xn square. Okay. So if you look at this one, the question that we have solved, this is the Hessian matrix for that one. Okay, is that clear, Aditya? Okay, any other doubts? Just I'll share a single resource also. Okay, so just wait a moment. This there you can understand clearly about the Hessians. Okay, I hope you can see this now. Okay, so can you see if the Hessian this is like a figure? So if the Hessian is a positive definite matrix, this is the figure. Okay, this is the figure. It will be like a convex thing. Okay, so it will be like concave up, you can tell. Okay, and if the eigenvalues are negative, it's said to be a negative definite matrix, or this is like a concave down. Okay, now if the eigenvalue is 0, or in the other case one positive one negative, like a saddle point, it will be like a concave up in one direction and a concave down in another direction. Okay, Ram, is that okay? So since like your saddle point comes in the univariate and the Hessian matrix is a similar case for the multivariate, a similar thing will be coming. It's kind of a saddle point. Okay. So anyone has any other doubt? I'll share this resource also in the PPT, all right? So that you can see that. Okay. So everyone, is that fine? Shall I stop the session now? Okay. So thank you. I'll be sharing the resources shortly. I hope everyone understood. Okay. So finish your assignments.